I'm Anil Kumar, and here is an excellent question on periodic functions shared by my student Maria. Now, in part A, we developed the equation for the periodic function representing this particular situation, and we kind of rushed through the later half of the solution. In this particular video, I'll concentrate more on the later half of the solution. Let's go through the question once again. It is a pedal on a bicycle has an arm length of 20 centimeters and rotates about an axle 32 centimeters above the ground. If pedal starts at its lowest point and rotates 20 revolutions every minute, find the sinusoidal function that will model the height h in centimeters of the pedal about after t seconds. At what time during the first 5 seconds will the pedal be 40 centimeters above the ground, right? So the situation here is, let us say this is the ground for us, and the axle of the pedal is kind of here, and that distance is 32 centimeters. On the other hand, the pedal itself has a length of 20. So that means it is moving, maximum could be 32 plus 20, and the minimum will be 32 minus 20. So we are starting from the bottommost point for the pedal. So the wave is kind of like this. So that is the wave, right? Now in this we analyzed that the axis here is, so this distance is 32 from here, right? And the amplitude, which is from here to the top because of the pedal, which will be 20 units, 20 centimeters. All these dimensions are in centimeters. Second, so we wrote our equation in the form of cosine graph. So we could write h of t, where time t is in seconds, as equals to minus, since it starts from the bottom, a cos of k t plus d, where d is the axis length. To find k, we have to find the time period. The pedal starts at its lowest point, therefore minus, and rotates 20 revolutions every minute. So it is 20 revolutions in 1 minute. That means 60 seconds. So 1 revolution in 60 seconds over 20, that means 3 seconds. So the time period here is 3. So if you see this time starting at 0, this will be at 3, right? So that will be at 6. So this point will be 1.5, 0.75 years, half of this, half of this. Kindly, you can add all these points here, 4.5. Right, so since time period is 3 seconds, so the value of k will be equals to how much? K is 2 pi by t, so it is 2 pi by 3. And therefore we got our equation as minus a is 20, the amplitude, cos of 2 pi by 3t, right? Plus d, the axis, 32 centimeters. So that is the equation for us, correct? So that is how we derived our equation. Now we will concentrate on at what time during the first 5 seconds will the pedal be 40 centimeters above the ground. Let's see how to solve this. So we'll say height is 40 centimeters. So I'm writing height as 40 centimeters equals to minus 20 cos of 2 pi by 3t plus 32. So let's take 32 on this side, becomes 40 minus 32. And then we'll divide by minus 20. So we'll divide in the next step. So we have minus 20 cos of 2 pi t over 3. So that is 8, right? This is 8. So let's divide 8 by minus 20, which is cos of 2 pi t over 3. So that is a negative number. So that is, we'll do 8 divided by 20. 2 over 5 negative. So it is negative 2 over 5. You could write in decimals. 0.4. So negative 0.4. So we have to do the cos inverse. So negative means what? For us, negative means, let me show it here. For the cos function, cos is, all are positive here, sine is positive here, cos is positive in quadrant 4, right? Negative means we are expecting the answer to be in quadrant 2, correct? So that means that cos is here in this quadrant, right? So this is our first quadrant. Quadrant 2 is this half. And obviously 40 you could see maybe somewhere here, right? So maybe 40 is somewhere here. So these are the values which we are expecting as a part of our answer, right? We'll check if this is within 5 or not, but definitely 3 are sure to be there. So what we will do now is we'll do cos inverse of 0.4 minus. So we'll do shift cos inverse of minus 0.4 equals to, we get 1.98. Now, so that is the value we get, 1.98. So let me write down cos inverse of, so we are just writing cos inverse of this. So I will do this calculation. I think I can squeeze it in. So cos inverse of minus 0.4 is equals to 1.9823. Let's take 4 decimal places. So that should be equals to 2 pi t over 3. You get the point, right? Now we will solve for t from here, okay? So we will do all these calculations on the right side of this page from now onwards. So we are going to use this space. Okay, so what is it? So if you have to find what t is, I'll have to multiply. So t equals to 3 over 2 pi times 1.9823, correct? So that is how I'm going to find t. So I'll do it times 3 equals to divide by 2 equals to divide by pi. So I get 0.946. So I get 0.946. We'll do 3 decimal places, that's good enough. So we got the first time here, which is 0.946. If I add the time period, I get the other one. So there are 3 times, let's say t1, t2, t3. There could be 4th also, okay? So we know t1, first time it reaches 40 is this. And we can write t3 also. We say t3 will be 3 plus 0.946, which is 3.946. But now we have to find the second time when it reaches. That means it is in quadrant 3. You get the point, right? Here also it will reach 40. So that point, how do we find this point? Now as you can see from the symmetry, this point should be same distance away from 3 as it is. This point is symmetrical, right? So I could reach, for example, I got this point. The other point is here, which is same distance away from 3, right? So if I do t2 the second time, I could do 3 minus 1.9823 to get the answer, correct? So let me do that. So we do, 3 minus 0. Okay, good, we found it. 3 minus 0.946. So this is the same distance away, right? So from 3 also it is same distance away. So we will do 3 minus 0.946 equals to, within decimals, it gives me approximately 2.05. Let me write 2.05. So that is the approximate value for the second time when it is at 40. Do you get the idea? Now, 4th time will be 3 away from here. So T4 will be 3 plus 2.05, which is 5.05. And that is not in our domain since we are looking for first 5 seconds. You get the idea? So we get our answer that the time for the paddle to reach 40 centimeters above is 0.946. 3.946 I wrote first, but I should have written 2.05. All are in seconds, okay? All are in seconds. So that is how you should be solving this question. I hope this calculation is now absolutely clear. If you have any more doubts, feel free to share with me. Thank you and all the best.